G'day, it's Clive Roxing here. Now, this is really critical. I've found out something amazing about designing transmissions. This is a transmission for the Terran Fireblade. These are the gears I'm going to be making. And what I do is I put it on the press and I actually punch out those keyways out of aluminium. So I can actually manually make gears at home. All I can do is get bright steel and make it the right shape and basically cut away those bits. But I found out in transmission design that, oh man, this is what the education system do, and it makes me so angry. What they've done is they make the focus ratios, right? No. It's got absolutely nothing to do with it. The main factor in the design of a transmission is the distance between the bloody shafts. Because what it is as you can see here, what I did was I put it in first, right? And I calculated the ratios out and I got 1341 RPM in first gear, right? It's got, I think it's going to have this particular one's going to have 2-speed, but it's got to have 6 gears at 20 mile an hour, supposed to get up to 120 mile an hour. This is the model for the Terran Fireblade. So this is going to be an active model. I've got to get this thing up to 120 mile an hour to make it equivalent to 300 mile an hour. I've calculated it out. So this is a model of the transmission, and that was first gear. Now second gear, this was the problem that I had. See how I've measured the shaft? The distance between the shafts. See, what you do is you've got to get the diameter exactly dead on between the two so that the gears mesh, and then you have to calculate all the pitches independently. So although these look the same, because it's so minute, every single one of these pitches on each one of these gears is different. They're all paired to one another. Like the pitch on this one might be a couple of thou different from the pitch on these two. You can actually see it there. See how the gears are wider? This is out of a 185 Quacker I pulled out. It's a transmission I wanted to study. And yeah, it turns out that when you design a gear, the first thing you have to do is determine how far you've got between the shafts. Then what you do is you measure the distance between the shafts. The easiest way that I did it was to make them even. What did I do with that? What I did was I made them even on either side and then multiplied it by the ratio. And then I wrote that on the bottom. The bottom one has to be bigger. So this one here had to be bigger. See how it's smaller there? That's a smaller ratio. That's going slower in first. This is second. It's got to have a bigger driving gear. Now that's on a spline, and this one's free floating, right? And that goes to your drive. So when you design a gear, the first thing you have to determine is the distance between the two shafts, between your lay shaft and your drive shaft. And then, and only then, once you have that exact diameter of each gear, less a couple of thou so that they don't touch, then you work out your pitch on one gear and then transfer that pitch onto the other gear and make it an even number and make darn sure that your ratios come out exactly right. And that's how you design a bloody transmission. It's got nothing to do with ratios, really, directly. Like ratios, yeah, they come into it, but that's not the deciding factor. And all I'm going to do, I'm going to make this transmission. These are the first 2 gears I've made up. These are 36 millimetre. The other one's 72 millimetre, which I've got to make up on the printer. And they'll make a ratio of 2 to 1. And then once I have those ratios sorted out, then I'm going to have to try and figure out this second set of gears, and I've got to come up with a ratio of 8.75 to 1. These ones are 2 to 1. So this particular set's a smaller one of 2 to 1. 7.2, 72 millimetre in diameter they're very large. It's going to be that big. I don't care how big this gearbox is, as long as it bloody well works. And I'm going to build a plastic one first, and then I'll build an aluminium one. So when you design a transmission, and all you have to do to change gears is you have a grabber gear that goes in between the two, and all you do is slide the grabber gear. So that's in second, that's in first, that's in second, that's in first. Easy as. So I'm going to design a 2-speed gearbox first and try and get it working. And I can drive my car with it. And I've actually pulled off, I've got a motor here. These are only $40. And these motors are insane, the power. This does 8,000 revs. This is just a fucking powerhouse, this motor. And the other one let's go over here for a second, is this is off a smaller one I bought. This was my first RC car, and I think you call this your ESCD. This is your this is the electronics that you turn on to make it work. That's your steering servo there, and I can get this to work. I've actually had that running in a car, and so what I'll have a battery driven gearbox, and it'll be a 2-speed, and that'll be the smaller one. It's going to be bloody huge. It'll be bigger than the motor, and that's your that's apparently all of your electronic paraphernalia to do with that out of my other RC car, and that's the motor which goes, and it's got it's got a gearbox. I'll have to take that off, and then when I get a bit more advanced, I'll probably design a bigger one for that one. And what I want to do is I want to machine the sleeve up so that it's not a gear, so that it's actually got a spline on it itself, and I'm going to use that liquid metal or that super hard Loctite and really lock the shaft on so it doesn't ever come off, and have a much bigger spline. I want a spline around about almost nearly the size of that gear, so it's got a flat spot on it instead of a spline. What do you call it? I want to put a flat spot on that, but I want the diameter nearly as big as that thing there, so I'll machine one of these. Well, I'll probably machine that particular one down to start with and use that. But what I eventually want to do is make a shaft up that's got a bigger flat on it, and then like Loctite the living hell out of it and put 2 screws in it and make sure it doesn't ever move. And that'll give me a much bigger working surface for these types of gears. I might even put a faceplate on it with small screws in it, so I can just put it onto it's only got to sit onto a base, and it'll get it all nice and neat. But yeah, transmissions, yeah, this is where they get you. They get you mucking around with ratios and that's got nothing to do with it, because your ratio is absolutely set by the distance between your 2 shafts. So you can forget all about, design the transmission, make that 3-to-1, 4-to-1. You can't do it like that, because the 2 shafts are set, they're fixed distance apart. And because they're fixed distance apart, when you design the ratios, those ratios have to be a balance between those between the distance of the 2 shafts.